Okay, good morning. Algebra 2 and Trig. I can't be there today, but I thought I'd present the lesson. It's pretty basic. It's called the natural log. This is section 7.6. I've discussed this briefly before, and I'm just going to formalize some of this information. All right, logarithms. Anytime your log is base e, we say that this is called the natural log. And the special notation for representing log base e is ln. All right. So the reality is, anytime you see ln, you should think that's just log base e, and you can rewrite that if you want. All right. Okay. But other than that, we'll be doing the same things with natural log as we did with any log with any base. All right. Let's take a look at a couple of examples where we're solving equations with logs or natural logs. Okay, this example right here, I've got the natural log of x minus 5 to the third power plus 4 equals 13. I want to solve for x. All right. Well, the first thing I notice is I don't like this 3 as an exponent. So I'm going to use the properties of logs, and I'm going to bring that 3 down in front of the natural log using the power rule, and I get the natural 3 times the natural log of x minus 5, and then plus 4 equals 13. Now, as we discussed yesterday, because there's only one log in this problem, I can't drop the log, so I'm going to have to convert to exponential form. To do that, I need to isolate this log expression. I subtract the 4 from both sides. I get 3 times the natural log of x minus 5 equals 9. Dividing both sides by 3, I get the natural log of x minus 5 equals 3. And at this point, I need to rewrite this log expression or log equation in exponential form. Now remember that this is the same thing as writing log base e of x minus 5 equals 3. Okay? So if I wrote this in exponential form, I would get e to the third power equals x minus 5. Now remember, e is that number 2.71, yada, yada, yada. I don't want to actually do that on my calculator. We're going to leave this in exact form, meaning no decimals. So my answer for x is, when I add 5 across, e to the third power plus 5 equals x. And that's my solution. Now, just to double check to make sure that this answer right here works in the log, e to the third power, gosh, well, that's somewhere between 2 cubed and 3 cubed. So that's going to be some positive number, plus 5 more is some bigger positive number. Well, if I put that into this equation, I know that this argument will stay positive. Right? So I avoid all extraneous solutions, therefore I know this answer works. All right, take a look at the next example. This example is an exponential equation. In this problem, my exponential is e to the x plus 1. Now, because there's only one exponential in this problem, I can't just drop the bases from each side and solve the exponents. So again, I'm going to have to isolate this exponential expression and then change forms from exponential form to log form to solve for x. All right, so the first thing I'm going to do is start off by adding 6 to both sides. I get 5e to the x plus 1 power equals 20. Dividing both sides by 5, I get e to the x plus 1 power equals 4. And now, because my exponential is isolated, I'm ready to write this in log form. In log form, this would be log base e of 4 equals x plus 1. Now, that x plus 1, or that log base e of 4, we're going to rewrite this as the ln of 4 equals x plus 1. Now, if I were you, the more practice you get, the better you're going to get at this. I typically will skip this step right here and go straight to this step where it just says the natural log of 4 equals x plus 1. Again, I could type in on my calculator using my ln button. I could just hit ln of 4 and get a decimal. But I'm going to leave my answer in exact form and just subtract the 1 across and get x equals the natural log of 4 minus 1. And that's my final answer. Remember that with exponentials, there's no restriction on the domain, so I don't have to worry about if this answer works or not. I know it's going to be just fine. And that's how I solve an exponential involving e. My answer is a natural log. All right, that's how we solve. Notice that you're using the same technique as we solve any log equation, no matter what the base is, or any exponential equation, again, no matter what the base is. That's all for now.